Hello everyone, welcome to our study today in the series which we are discussing on the uniform linear motion, and now we are considering the vertical projection and body which is projected vertically upward. Today we want to look a bit of the numerical example whereby we are considering a body which is projected vertically upwards, and it is projected with initial velocity 30 meters per second. You are required to find part 1 of this question. You are required to find the time taken to reach maximum height. So what we are going to do, we are going to employ the standard equation of a uniform linear motion equation for a body which is projected vertically upwards. So V stands for the final velocity is given by U minus gt. Here, V final velocity, U initial velocity, G acceleration due to gravity, and T is the time. So the question requires you to find the time taken to reach maximum height. At maximum height, our final velocity is given by 0 meters per second. 0 meters per second at at maximum height. So we substitute 0 here. So we are going to have 0, which is equal to our initial velocity is 30 meters per second, which is equal to that minus g. Here you have to take g. Take g is equal to 10 meters per square second. So minus 10t. What we are going to do at this level, you are going to take negative 10 on the other side, so you have to make it positive 10 is equal to that. So we divide both sides by 10. We divide both sides by 10 to obtain our t is equal to 3 seconds. So that is the time taken by the body to reach maximum height. Part B of this equation is this one. You are required to find the time of flight, time of projection, or of time of the projector. So this is the time taken by the body to move and return back to the position where it was projected. So we are going to use this equation. S is equal to ut minus g t squared divided by 2. So that is the equation we are going to employ. Now, at the time when the body has returned to the point where it was projected, the displacement will be equal to 0, because the upward distance is positive and the opposite distance will be negative. So when you add, you are going to get 0. So we substitute 0 here. So we have 0 is equal to ut minus half gt squared. We can factor t here, t into bracket, u minus half gt. What we are going to do now, we are going to equate to u, this other part, minus half gt squared. No, sorry, this one. This is just t, because we factored t outside. So here we will have t. So we have factored t outside here to be left with u minus half gt. So this is equal to 0. Now we equate our values. We know that our initial velocity, we are given here, it is 30 meters per second. And we are given in g, our g is, we are going to take our g as 10 meters per second. So we substitute here. So we have that minus half times 10 t. This will give us 0. So here you have that minus 5t, which is equal to 0. That is equal to 0. You can see, you can take negative 5 the other sign to make it positive. That is equal to 5t. Meaning that now t will be given by that divided by 5. That divided by 5 will give you 6 seconds. 6 seconds. Alternatively, if you remember, the time of flight is twice the time taken to reach maximum height. So if you remember, you can simply get t, capital T, which stands for the time of flight, as 2 times 3, which will give you 6. Of this question, it is whereby now you are required to obtain the maximum height. So you are going to use this equation: v squared is equal to u squared minus 2gs. We are going to imply the fact that at maximum height, this final velocity v is, will be equal to 0. So we are going to equate 0 here. So 0 is equal to u squared minus 2gs. We know u. 0 is equal to that squared minus 2 times 10 times s. When you square that, it is going to give you 900. 2 times 10 is 20s. The objective is to get maximum displacement. So 20, you take 20 the other side to make it positive. 20 plus 0 will give you 20 is equal to 900. Is equal to 900. So we want s. S is equal to 900 divided by 20, which is equal to, by 0, 45 meters. So our maximum height attained by the body is 45 meters. Alternatively, in case if you remember this formula, maximum height is given by u squared divided by 2g, which is equal to that multiplied by that, and you divide by 20, which is the same as the one which we have there. To obtain 0 by 0, this is 45 meters. 45 meters. Now, question part D of this problem. Part D of this problem is velocity of return. Velocity of return. So velocity of return, we are going to employ this equation. V squared is equal to u squared minus 2gs. Now, at the point of return, when the body is returning, the displacement is equal to 0 meters. 0 meters. So, we are going to have v squared is equal to u squared minus 2g multiplied by 0. So, v squared is equal to u squared minus 0. With v squared will be equal to that times that. We're interested with the v. So to get v, we get square root both sides. So v is equal to plus or remind us that V is equal to 30 meters per second. So that is how you solve the numerical questions on the concerning the vertical projection. You can also watch out for my other presentation on the horizontal projection and on the numerical aspect of the body which is projected horizontally, and also on the body which is moving linearly with their uniform speed on a straight line, so that you may have an idea of how the working is done. Thanks so much for watching this video. Kindly all the time remember to like, uh, to subscribe, and also to share with the other scientists, particularly those who are interested in physics, so that they may get the knowledge which is needed for their study. Bye bye. See you in the next video, which I upload every day concerning physics. Particularly now we are looking at uniform linear motion.